This is section 12.8, solving general triangles. So we're going to be solving all triangles, whereas before we only solved right triangles. And we're going to use the formulas from the law of cosines and the law of sines to do so. How do we solve any given triangle? Remember, to solve a triangle, you need to figure out all the sides and all the angles. So, solving triangles can be divided into 4 different cases. 1. We could be given all 3 sides. That's the SSS case. Some of these abbreviations should seem somewhat familiar to you based on what you remember in geometry. You could also be given SAS, which would be the 2 sides and the angle between those 2 sides. So the angle letter would be different than the side letters. You could also be given SSA, which is given 2 sides and an angle opposite one of the sides. Now, if you remember, SSA was the situation where you could not prove triangles congruent. Finally, we have either ASA or AAS. We're given any 2 angles and one of the sides. And how you treat all 4 of these are somewhat different. I will give you an approach to each one, which you can either memorize or just figure out. Mainly, you can figure out just by what you have to do. And then you actually have to do the calculations. So here we go. SSS, we're given all 3 sides. The basic strategy is this. You're going to use the law of cosines to find the angle, because the law of cosines, you need all 3 sides to figure out the included angle to 2 of the sides. You will then use the law of sines to find a second angle, and finally you will take the 2 angles you know, subtract them from 180 to find the third angle. So you're going to use the law of cosines when you use side, side, side. Now, you'll remember this because if you try to use law of sines, it won't work because you'll have the sides, but you can't solve any of the ratios because you don't know any of the angles. Example 1, this is an SSS case. You have side A is 5, side B is 6, and side C is 7. So let's follow the approach that I gave you on the previous slide. Use the law of cosines to solve for one of the angles. So it doesn't really matter which one you pick. I'll solve for angle C because this is the most familiar form of the law of cosines formula. So you just plug in the numbers for cosine C. You can do this first, which is what I did. And you get cosine C is 0.2, which means C has to be 78.5 degrees. So you're basically using the law of cosines formula. I've rewritten it in terms of cosine C by subtracting C squared from this side, adding the 2AB cosine C to this side, dividing both sides by 2AB, plugging in numbers. Cosine C is 0.2, therefore C is the inverse cosine of 0.2, or 78.5 degrees. So we now know one angle. We now use the law of sines to solve for a second angle. So law of sines tells us that sine B over B equals sine C over C. You could have used sine A over A, it doesn't matter. So let's plug in the numbers. We know side B is 6. We know now the angle is 78.5, and we know that side C is 7. And all you have to do now is solve for B. So sine B is equal to 6 times sine of 78.5 divided by 7. Multiply both sides by 6. So sine B is 0.8398. Take the inverse sine of both, and you get that angle B is 57.1 degrees. Alright, now the only thing left is to find angle A. We can do that easily by taking the sum of angles B and C and subtracting that from 180. So angle A is 44.4 degrees. So again, with a side, side, side case, you are going to use the law of cosines to find one of the angles. You have use the law of sines to get the second angle, and then figure out the third angle by subtracting the 2 angles you know from 180. You'll be doing some examples on this, so even though you won't get a lot of practice during these notes, you'll have chances to do it tomorrow in class. Our second scenario is given SAS. We're given 2 sides and the angle in between those 2 sides. So the strategy here is to use the law of cosines to calculate the third side of the triangle. Secondly, you're going to use the law of sines to solve for one of the 2 unknown angles. Finally, you're going to take the angles you know, subtract their sum from 180 to get the third angle. Alright, I'm going to give you a problem, exercise 2. I want to see if you can do all 3 of these things by yourself. The approach is very similar to what we do with SSS. You have all the information you need. So go ahead and try to solve this one. You have side A is 5, side B is 6, and angle C is 80. This is an included angle because it's in between sides A and B. So try to do this one yourself using the strategy I had on the previous slide. All right, so we're going to first use the law of cosine to solve for the third side. So c squared is a squared plus b squared minus 2ab cosine c. You're going to plug in 5 for A, 6 for B, and 80 degrees for angle C. And you eventually get c squared is 50.58 or c is 7.11. All right, now that we know side C, what do we do next? We use the law of sines to solve for one of the two unknown angles. So let's again use angle B. Sine angle B over B is equal to sine angle C over C. So let's plug in the values that we know. Sine B over 6 is equal to sine of 80 over 7.11. So B is equal to 56.2 degrees. All right, so now that you know two of the angles, you can solve for the third angle. A is 180 minus 56.2 minus 80, or 43.8 degrees. So you figured out the three unknown parts of the triangle based on the SAS that you had before. So again, if you are given two sides and an included angle, you're going to use the law of cosines to get the third side, use the law of sines to find one of the two unknown angles, and then subtract the two known angles from 180 to get the third angle. Alright, now we have the SSA scenarios. You are given two sides and one of the angles that is not the included angle. So, as you remember from geometry, you cannot use SSA to prove triangles congruent or similar. Likewise, when you try to solve a triangle with SSA, you have to consider there are many possibilities, including one with two solutions, and the possibility that you don't even have a real triangle. So this is going to be the most involved of all four scenarios, and I'm going to go through the 6 possibilities based on what is in your textbook on page 592. So if you want to look in your book, that's fine. Otherwise, follow along. The first 4 scenarios will cover acute angles. The last 2 scenarios will cover obtuse angles. This will get you started in terms of what the possibilities are. Now, once you figure out what that is, or you can even actually skip this step, you're going to use the law of sines to calculate one of the other 2 angles. All right? Now, there might be one solution. There might be 0 solutions. There also might be 2 solutions, and we'll see why in a minute. Next, you're going to take the 2 known angles, subtract them from 180 to get the third angle. And again, there might be more than one solution, because if you have 2 solutions to angle number 2, you'll have 2 solutions to angle number 3. Finally, you're going to use the law of sines to find the third side, considering all possible solutions. So this is the most involved by far of the 4 scenarios. Let's see the 6 different possibilities. Let's first consider the possibilities where the given angle is acute. So we are going to be given angle A, side B. And let's start with the presumption that angle A is acute. So there's angle A. Let's use this. B sine A is basically B times sine A. Now remember, this were a height. This were a right triangle. Sine of A would be the opposite over the hypotenuse. So the height would be the hypotenuse times sine A, just by rearranging the formula. So let's first consider, if A is less than the height of the right triangle, then there is no solution. Think of this as a door, and it's just not long enough to reach the bottom here. So if A is less than B sine A, there's going to be no solution. And the reason is, if you plug in the formula to the law of sines, you'll end up with the sine of angle B being greater than 1. And sine cannot be greater than 1. So there is no solution if A is less than the height of whatever this right triangle would be. Again, think of side A here as a hinge, or as a door on a hinge. It can't quite reach the other side. So that's possibility number 1. Number 2, A is exactly B sine angle A. So you basically would have a right triangle. There is only one solution, because this side here, A, would hit this base exactly where this is a right triangle. So there's only one solution, if A is equal to B sine A, which basically would be the sine is equal to opposite over hypotenuse. Situation 3. This is called the ambiguous case. Ambiguous meaning there is more than one meaning or one possibility. So if B sine A is less than A, but A is also less than B, you're going to have two solutions. Again, think of side A as a door on a hinge at point C. And if you open it and swing it around, it hits the base at exactly two spots. All right? So this is the case where your sine of B is going to be less than 1. But once you add up angle A and angle B, you're going to have two numbers that add up to less than 180. So you'll have two possible values for angle B. There will be times when you figure out that angle B plus angle A will be greater than 180 if you do a second possibility. Then you do not have the ambiguous case. We'll look at this in example 3, but this is the thing you want to look out for. If A is between the height of the right triangle and side B, you're going to have two solutions. So check your sign, and we'll see how that works in a few minutes. Possibility 4, if you have an acute angle and A is longer than side B, then you're only going to have one solution. And if you take a look at how this hinge works, if you try to swing it all the way around to the other side, it's too long. All right, so that's how this works. What if we have an obtuse angle? Now let's consider the possibilities if angle A is a right angle or an obtuse angle. This is pretty simple. If angle A is right or obtuse, then side A has to be the longest side in the triangle, because if angle A is right or obtuse, it's going to be the biggest angle. So if A is less than B, side A is less than side B, you're not going to have a solution, because again, this makes sense. If angle A is obtuse or right, then side A must be the longest side. And if you take a look at again this hinge, it's sadly not long enough to connect the triangle. So if A is greater than B, you're only going to have one solution, which again makes sense, because once you have an obtuse angle or right angle, you can't possibly have two solutions. So those are the 6 possibilities. Let's take a look at the next example. If we're given that angle A is 21.6 degrees, side B is 29.7, and side A is 10.7, solve the triangle. All right, so we have an obtuse angle here, which means we're going to be looking at 4 possibilities, possibly. So let's first use the law of sines to find one angle. That's the step 1. So sine A over A is equal to sine B over B. Plug in the numbers, and you will see that sine B is equal to 29.7 sine 21.6 over 10.7. And if you figure that all out, you get 1.021. But this is impossible, because the sine of B can't be greater than 1. So there is no solution. All right? And this makes sense, because if you get a B that's too big, it's not going to work for a triangle. And that's basically what happens. So there's no solution to this one, example 3. And this is a possibility when you have an acute given angle and the sine of the other angle with the side you're given is greater than 1. Example 4. Now we're given side A is 15, side C is 18, and angle A is 32 degrees. Solve the triangle. All right, so there is our triangle. It's not very obvious. This should be a 32 degrees. I was too lazy to put it in there. But there are going to be 2 possibilities, and let's see how it works. Use the law of sines to find one angle. So we use sine of A over A equals sine of C over C. And if you do the math, you get that C is either 39.5 degrees. If you plug in your calculator, you get 39.5 degrees for the inverse sine of 0.6359. However, if you remember, sine is also positive when the angle is between 90 and 180. So another possibility is that angle C is also 140.5 degrees. So this is the ambiguous case, because you have 2 possible values for angle C. If you have 2 possible values for angle C, you have to have 2 possible values for angle B. So angle B is either equal to 180 minus 39.5 minus 32, which is 108.5, or angle B is equal to 180 minus 32 minus 140.5, or 7.5. So this little angle there represents the 7.5. This big angle B there represents the 108.5. Again, there are 2 solutions. How do you know? Because if your sine of C is less than 1, you have to consider the possibility that there are 2 answers. And you might always want to do this just as a habit, because you're always going to get 2 numbers between 0 and 180 for the angle C. The thing that makes it one solution or two solutions is whether this larger angle makes it so that this plus the given angle are greater than 180. If this plus your given angle are greater than 180, you can throw this one out because you won't have a real triangle. But if it doesn't, this is when you have the ambiguous case. Alright, now that we have two of the angles, let's find the third side, because we know all three angles now actually. So sine of 32 over 15, which is sine of A over A, is equal to sine of angle B over side B. And if you solve for side B, you get 26.8. Now, if you have the second case where B is 7.5 degrees and C is 140.5 degrees, you're going to use the same formula to solve for side B, except you're going to plug in angle B up here. So, doing the same type of math, you get the other possibility for side B is 3.69. And if you look at the previous slide to see the triangle, you can see the difference in the lengths of side B. This one is very stubby and short. This one is much longer. So, with the ambiguous case, again, check your sign. Your inverse sign should get you two numbers that both give you possible triangles. If you're given a second angle, the larger angle for the inverse sign, and it puts you over 180 when you're adding it to the given angle, you can throw that one out. Alright, the last scenario is if we have angle side angle or angle angle side. This is pretty simple. When you're given two angles on any side, you're first going to find the third angle by taking the two known angles and subtracting them from 180, and then you're going to use the law of sines to calculate the other two sides. So I think you can do example 5 by yourself. Try this one. Angle ABC, triangle ABC. Angle A is 20, angle B is 60, and side C is 10. Try to do this one yourself using the strategy I gave you. Alright, so here we go. First find angle C. Angle C is going to be 180 minus 60 minus 20, or 100 degrees. Now you're just going to use the law of sines to figure out sides A and B. So, first let's figure out what side A is. Sine A over A is equal to sine C over C. So sine of 20 over side A is equal to sine of 100 over 10. So A is equal to 10 sine 20 over sine of 100, or 3.47. Now let's try to figure out what side B is. Again, sine B over B is sine C over C. Plug the values in, and you see that B is 8.79. Again, for the angle side angle or angle angle side, first find the third angle, then use the law of sines to calculate the other two sides by putting it over the ratio that you know between the angle that you have figured out and the side that they give you. Example 6. A biologist tracking an animal with a radio transmitting collar detects the animal in a line that is 27.5 degrees off the trail. After moving 155 meters down the trail, the line to the animal is 38.8 degrees off the trail. Assuming that the animal hasn't moved, find the distance QA between the biologist and the animal. So we're looking for this distance here. Now, fortunately for you, or maybe not, you probably can figure this out yourself, I gave you a picture. You start here, the angle to the animal is 27.5 degrees. You go down the trail, assuming it's straight, which you kind of have to, and now the angle here is 38.8 degrees. Figure out what QA is. See if you can do that based on what you know and what you know about figuring out what the measures of angles are. Alright, there's our picture. First, we need to find angle A, and we can do that using the exterior angle theorem. If you do not remember your geometry, you'll remember that the exterior angle of a given angle is equal to the sum of the two other angles. So, 38.8 is equal to 27.5 degrees plus angle A. So angle A is 11.3 degrees. There it is. Now, you have two angles and one side, so you are going to use the AAS approach. Now, you figured out all three angles. You actually don't need all three angles because you just have sine 11.3 over 155 equals sine of 27.5 over QA. So, solve for QA by doing this simple ratio, and QA is 365 meters away. Now, what's the likelihood that an animal won't move? I suppose if it's a sloth, it's pretty possible. Alright, that's the end of section 12.8. It's a long one. try to go over stuff you don't understand, and you'll have plenty of practice in class to do problems. If you have any questions, please ask me in person or over the internet.